Hey everyone, welcome back to the channel. In this video, we're going to explore the biomedical engineering aspects of uroflowmetry. If you're new here, make sure to subscribe for more awesome videos. Let's dive right in. So first off, what is a uroflowmeter? Well, it's a device that measures how fast urine flows from the body when you pee. It does this by turning the weight or volume of urine into an electrical signal that can be measured. There are two main ways that uroflowmeters work. The first is the gravimetric method, which is like a bathroom scale for urine. The urine is collected in a container on top of a load cell, which is a fancy weight sensor. The flow rate is then calculated by measuring the change of weight over time. The second method uses a rotating disc that spins as urine hits it. The faster the urine flow, the faster the disc rotates, so the device can calculate the flow rate based on the rotation speed. Some advanced devices use electronic flow sensors like ultrasonic or capacitance sensors to measure the flow rate. Once the uroflowmeter is set up, it records several key parameters. The first is Qmax, which is the maximum flow rate during urination. This is measured in milliliters per second. Cav is the average flow rate, which is the total volume of urine divided by the time taken to urinate. Voided volume, or void, is the total amount of urine passed during the measurement. Voiding time is the total duration of urination. And finally, the flow curve, which is a plot of flow rate against time, gives a visual representation of the stream of urine. Now let's talk about how doctors interpret these results. In a normal, healthy bladder with no obstruction, the flow curve will be bell-shaped. This means that the urine stream starts slow, reaches a maximum flow rate, and then slows down again. However, if there's an obstruction in the urinary tract, such as an enlarged prostate in men, the flow curve will be low and flat, indicating a weak urine stream. This could also be the case if the bladder muscles are weak. In addition, if the bladder is not squeezing properly, the voiding time will be longer than usual. Lastly, if there is a problem with the nerves that control the bladder, such as with multiple sclerosis, the flow curve may be interrupted or irregular. This is because the nerves are not sending the right signals to the bladder, causing it to contract and relax abnormally. Uroflowmetry is a simple but powerful tool in the urologist's toolbox. It helps them diagnose a number of conditions, including benign prostatic hyperplasia, or BPH, in men, where an enlarged prostate gland is causing urinary symptoms. It's also used to detect urinary incontinence in women, which is the inability to control the flow of urine. Doctors also use uroflowmetry after surgery to monitor how well the patient's urinary function is returning to normal. And it can also be used in children to check for urinary tract dysfunction. The great thing about uroflowmetry is that it's a non-invasive test, meaning that the patient doesn't need to be cut open or have any needles inserted. All they have to do is urinate normally into a container while being hooked up to the machine. Nowadays, many uroflowmeters are digital, which means they can provide a real-time flow curve on a display screen. This allows the doctor to see the patient's flow rate and adjust the collection container as needed. Some uroflowmeters are portable, which means they can be used in clinics or even at home for monitoring patients over time. Additionally, the test is often combined with a post-void residual urine test, which is also done with ultrasound to measure how much urine is left in the bladder after urination. And that's it, folks. We've covered the basics of uroflowmetry and its applications in diagnosing and monitoring various urinary conditions. If you enjoyed this video, please hit the thumbs up button and share it with your friends. Thanks for watching, and I'll see you next time.